Hello, I'm going to talk to you about the Department of Physics and Astronomy at the University of Iowa. My name is Professor Jane Nachman, and I am the Director of Undergraduate Studies in our department. So I'm going to give you an overview of the physics program, and then we'll have an overview of the astronomy program, and then we will talk about more research opportunities at the University of Iowa. So I'd like to just start with an overview of our program and talk a little bit about our students and opportunities at Iowa. First, I'd like to just think about what types of students might want to major in physics. Physics generally attracts students who are curious about why and why the world works the way it does, how things work. So you can think of a physics degree as sort of a technical liberal arts degree, and there are many directions possible. As you think about your career. Our students go into medicine, engineering, or other technical fields. Some go into law, computer science, or stay in academia. At the University of Iowa, we've designed our program to let students explore a broad spectrum of career opportunities so that they're ready for the next stage of their life. We do this by providing advanced electives and many opportunities for research with faculty and a great deal of community engagement. I'd like to talk a little bit about the undergraduate physics curriculum. In our program, we offer a Bachelor of Arts and a Bachelor of Science. So many students actually pair the physics degree with a degree in astronomy or math, a double or even a triple major. We also have an interesting applied physics option. So this is often a second degree, where someone may have another degree in computer science, and then they pair it with an applied physics degree. So we have subtracks for applied physics in medicine, computer science, photonics, and solid-state physics. This degree comes with an internship opportunity, so that you really can get a feel for what you might want to do next. A highlight of our program is that first and second year physics and astronomy majors follow a 4-semester introductory sequence when they come to the University of Iowa. This gives an in-depth introduction to fundamental physics topics. It also allows us to have small class sizes, so you really get to know your fellow students and you really build a sense of community. We also have elective courses in a wide range of topics for students to delve deeper into what they may be interested in doing. For example, we have nuclear particle physics, optics, astrophysics, plasma, solid state, and computational physics, as well as all of the astronomy courses. As I said, a highlight of our program is the ability of our undergraduates to get involved in research. Many undergraduate students work with faculty in labs and experimental and theoretical projects. There is the opportunity to travel to worldwide facilities such as Fermi National Accelerator Lab, CERN, National Radio Astronomy Observatory, and NASA labs. And many undergraduates publish papers and present at conferences. Here we see 4 undergraduate students with one of their posters, which was presented at a conference. And here we see 3 of our students who were able to travel to Norway to a rocket school, and they were actually able to build and fly a rocket. Our graduate program offers degrees, master's and PhD degrees in physics. Many graduate students also have the opportunity to teach undergraduate labs as a way of supporting their education for the first year or two. And then when they get into research, the students choose from a wide range of research areas. And we will hear more about these in a few minutes. We have plasma, space physics, condensed matter physics, optics, and nuclear particle. Students have an opportunity to choose from theoretical or experimental work with faculty mentors, and we have excellent, fully equipped on-campus research labs, as well as access to the world's leading off-campus facilities, including accelerators, observatories, and spacecraft. We have research funding available from external funding agencies to fund your research as you complete your degree. And our internationally recognized faculty includes 12 fellows of the American Physical Society, 2 fellows of the American Geophysical Union, and a member of the National Academy of Sciences. A a great way to build community at the University of Iowa is through organizations such as the Society of Physics Students. This is a nationwide organization, and the University of Iowa has an active SPS chapter. So you'll see some here some students engaged in some outreach activities, and that is one of the focuses, as well as career building activities. So they have a host of activities. Here shown a field trip to Fermilab. Here's a Learn to Solder night. They also have dinner with faculty members, holiday events. They work on graduate school prep, host public observing nights with the Van Allen Observatory, and have homework get-togethers and game nights. So there's a lot of great opportunities to get to know other physics students at the University of Iowa. So if you would like more information, I hope you will contact us. Here is my email address, and now I will turn it over to Professor Casey DeRue, who will talk to about astronomy.
Hi, my name is Casey DeRue. I'm an assistant professor here at the University of Iowa in the Department of Physics and Astronomy, and I want to talk to you today about studying astronomy at the University of Iowa. Our department has specialties in observation, instrumentation, and theory, and so let's get started. So students who come to the University of Iowa to study astronomy might go under two tracks. We offer both undergraduate and graduate programs. So in the undergraduate track, we have curricula for both a Master or a Bachelor of Arts and a Bachelor of Science. And most of our undergraduate students choose to pair this with a degree in physics as well, so that they double major in both physics and astronomy. It's also very easy to add a math minor, which is a popular track for many of our undergraduates, though certainly not a requirement. In terms of graduate studies, we offer both an MS or PhD option. Many of our graduate students have elected to go the PhD option, stopping for a master's degree along the way after completing their comprehensive exam. In terms of astronomy, we have a particular astronomy subtrack. So your degree is granted in physics, but you have a specialty or a subtract in astronomy with graduate curricula to match, so that you are studying things like the interstellar medium or high energy astrophysics. We also have a rich research community for both undergraduates and graduates. So we have an ongoing weekly seminar with space physics. We have a very active space physics department. We have, again, like I mentioned, the seminars, public outreach opportunities. Here in Van Allen Hall, where we're located, just above me now, is the Van Allen Observatory, which is on the roof. This is a 0.43 meter instructional telescope that students, both undergraduate and graduates, have the opportunity to use and get trained on, both for using for research as well as astronomical instrumentation. In addition, we have a number of research opportunities. Our faculty use facilities all over the world and use research grade telescopes. So as I mentioned at the start of my talk, we have specialties in both theory, observation, and instrumentation. As of fall of 2021, we'll have 5 faculty who are research active in our astronomy department in particular. And when you think about the sum of those faculty, we really have emphases in both high energy instrumentation and extragalactic astronomy. So this GIF that you're seeing play here as an example is a CubeSat called HaloSat that was deployed from the International Space Station. It's been taking measurements of the hot X-ray halo of our Milky Way galaxy for about the past 2 years. It's PI'd by it's led by a member of our department, Phil Carrot, up here. And they've actually just recently published their findings in Nature Astronomy. Undergraduates and graduate students were a core part of the design, the build, and the operation of HaloSat to get those data and are the subject of a couple of PhD theses as well as several papers in the Astrophysical Journal as led by undergraduates. We also have emphases in extragalactic astronomy to highlight one particular study. This is a study done by an undergraduate led by Hai Fu, who is a specialty or a specialist in thinking about high redshift galaxies. And so here, Hai applied for and successfully got time on ALMA to study a massive starburst galaxy at really high redshift to work out the dynamics. So it's a very brief outline of everything that we've got going on here at the University of Iowa in terms of astronomy. If you're interested or want more information, please contact us. I've left my contact information here on the screen, as well as our webpage. You can also reach me on Twitter. Thank you, and we hope to see you at the University of Iowa.